The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
Picture this, a world so mysterious and distant that it takes sunlight over 5 hours to reach it. A world that was once considered the 9th planet in our solar system, then stripped of that title, only to become even more fascinating than we ever imagined. I'm talking about Pluto, and what the James Webb Space Telescope just discovered about this icy dwarf planet will completely change how you think about our solar system. What if I told you that right now, as you're watching this video, there's a ghostly blue haze swirling around Pluto that's controlling its entire climate in ways we've never seen anywhere else in our solar system? What if I told you that this distant frozen world has weather patterns so unique that scientists are calling it a completely new type of climate system? Well, hold on to your seats, because that's exactly what the most powerful space telescope ever built has just revealed to us. The James Webb Space Telescope has been peering deep into space since it began operations, showing us galaxies from the dawn of time and planets around distant stars. But sometimes, the most incredible discoveries happen right here in our own cosmic neighborhood. And Pluto, sitting out there in the cold darkness at the edge of our solar system, has just surprised us once again. For decades, Pluto remained one of the most mysterious objects in our solar system. When NASA's New Horizons spacecraft flew by Pluto in 2015, it gave us our first close-up look at this distant world. Scientists were amazed to see a surprisingly active planet with towering mountains, vast plains, and most intriguingly, a blue atmospheric haze that gave Pluto an almost ethereal appearance. But back then, we could only guess what that blue haze was doing to Pluto's environment. Now, nearly 10 years later, the James Webb Space Telescope has turned its incredible instruments toward Pluto, and what it found has scientists completely rethinking everything we thought we knew about this distant world. Using its advanced heat sensing capabilities, Webb has discovered that Pluto's mysterious blue haze isn't just pretty to look at. It's actually the master controller of Pluto's entire climate system, working like a cosmic thermostat in ways that exist nowhere else in our solar system. Let me paint you a picture of what's happening out there on Pluto right now. Imagine a world where the sun appears as nothing more than a bright star in the sky, providing barely any warmth at all. The average temperature on Pluto is around negative 375 degrees Fahrenheit. That's so cold that the air itself would freeze solid here on Earth. But Pluto does have an atmosphere, thin as it may be, made up of nitrogen with traces of methane and carbon monoxide. Now, here's where things get really interesting. Surrounding Pluto is this blue haze that scientists have discovered is made up of tiny particles of nitrogen, methane, and carbon dioxide. These particles are so small that they're invisible to the naked eye individually, but together they create this ghostly blue veil that wraps around the entire planet. And here's the mind-blowing part. These tiny particles are actively controlling Pluto's temperature by absorbing and reflecting heat in incredibly complex ways. Think of it like this. On Earth, our atmosphere works kind of like a blanket, trapping heat from the sun and keeping our planet warm enough for life. But Pluto's haze works more like an air conditioner. Instead of trapping heat, it's actually cooling the planet down even further than it would be without the haze. The James Webb Telescope measured exactly how much heat these haze particles absorb and emit, and scientists discovered that they're making Pluto's atmosphere significantly colder than it would be otherwise. But wait, it gets even more fascinating. This isn't just a simple cooling system. The haze particles are constantly changing, heating up and cooling down in response to the incredibly faint sunlight that reaches Pluto. As they heat up, they release energy in very specific ways. As they cool down, they absorb energy from their surroundings. This creates a complex dance of energy exchange that scientists are calling a completely new type of climate system, unlike anything we've ever seen before. Dr. Tanguy Bertrand, an astronomer at the Paris Observatory who led this groundbreaking research, described this discovery by saying that this type of climate control is completely unique in our solar system. While other planets have weather systems driven by temperature differences, wind patterns, or seasonal changes, Pluto has a climate that's controlled by microscopic particles floating in its atmosphere. It's like discovering that a distant world has its own built-in air conditioning system that we never knew existed. But the James Webb Telescope didn't stop there. Its observations revealed even more incredible phenomena happening on Pluto that sound like something out of a science fiction movie. The telescope detected seasonal cycles of ice moving around on Pluto's surface. Imagine vast sheets of frozen nitrogen, methane, and carbon monoxide constantly redistributing themselves across Pluto's landscape as the seasons change. And remember, on Pluto, seasons last for decades because it takes 248 Earth years for Pluto to complete one orbit around the Sun. Even more incredible, Webb discovered that material is actually being pulled from Pluto's atmosphere and transferred to its largest moon, Charon. Picture this. Gases from Pluto's atmosphere are somehow escaping the dwarf planet's weak gravity and traveling the 12,000 miles to Charon, where they're being deposited on its surface. This kind of atmospheric transfer between a planet and its moon doesn't happen anywhere else in our solar system. It's an eerie, otherworldly interaction that shows us just how dynamic and active these distant worlds really are. What makes these discoveries even more remarkable is how the James Webb Telescope was able to make them. Unlike the beautiful visible light images that Webb is famous for showing us of galaxies and nebulae, studying Pluto required looking at heat signatures and infrared light. Webb used its mid-infrared instrument, or MIRI, to measure the exact temperatures of different parts of Pluto and its atmosphere. It could detect temperature differences as small as a few degrees across Pluto's surface and precisely measure how much heat the atmospheric haze was absorbing and emitting. This kind of detailed thermal mapping would have been impossible with any previous telescope. Webb's mirrors are so large and its instrument so sensitive that it can detect the faint heat signature of Pluto's haze from over 3 billion miles away. To put that in perspective, that's like detecting the heat from a candle flame from the distance between Earth and the Moon, except the candle is thousands of times further away and the flame is thousands of times smaller. The implications of these discoveries extend far beyond just understanding Pluto better. Scientists believe that studying this unique climate system can help us understand the atmospheres of other distant worlds, including planets orbiting other stars. Many of the exoplanets we discovered are cold, distant worlds that might have similar atmospheric conditions to Pluto. By understanding how Pluto's haze control climate works, we might be better able to interpret observations of these distant alien worlds. There's also an intriguing connection to Earth's ancient past. Billions of years ago, when our planet was young, it may have had atmospheric conditions somewhat similar to what we see on Pluto today, with complex organic particles floating in the air. Some scientists think that studying Pluto's atmospheric chemistry could give us clues about what Earth's atmosphere was like in its earliest days, before life began to change its composition. But perhaps the most exciting aspect of these discoveries is what they tell us about the incredible diversity of worlds in our solar system. For so long, we thought of Pluto as a cold, dead, inactive world sitting at the edge of our solar system. The discovery that it has this complex, unique climate system shows us that even the most distant and seemingly inactive worlds can surprise us with their hidden complexity. The research team used Webb to observe Pluto during 2022 and 2025, capturing snapshots of this distant world during what amounts to early winter at its North Pole. Since Pluto's orbit takes 248 years, these observations are just seeing the beginning of a seasonal cycle that will continue for decades to come. Scientists are planning to continue monitoring Pluto with Webb over the next decade to see how its climate system changes as it moves further from the sun and its winter deepens. What's particularly exciting is that this is just the beginning. Webb's observations of Pluto have opened up an entirely new way of studying the outer solar system. The telescope's incredible sensitivity means it can detect phenomena on distant worlds that we never knew existed. Scientists are now planning similar observations of other objects in the outer solar system, including other dwarf planets, large asteroids, and the moons of the giant planets. The story of Pluto itself is a perfect example of how science constantly surprises us. When Clyde Tombaugh discovered Pluto in 1930, he was looking for a large planet that was disturbing the orbit of Neptune. What he found was a small, distant world that challenged our understanding of what a planet should be. In 2006, Pluto was reclassified as a dwarf planet, which some people saw as a demotion. But discoveries like this show us that Pluto is far more interesting and complex than we ever imagined when we thought of it as just a ninth planet. The fact that we're still making groundbreaking discoveries about Pluto in 2025, nearly a century after its discovery, shows us how much we still don't know about our own solar system. Every time we develop new technology and new ways of looking at space, we discover something that completely changes our understanding. The James Webb Telescope is giving us eyes that can see things we never imagined, and Pluto's atmospheric haze is just one example of the incredible phenomena that have been hiding in plain sight, waiting for us to develop the technology to detect them. As we continue to explore our solar system and search for life on other worlds, discoveries like this remind us that the universe is full of surprises. Climate systems we never imagined, atmospheric phenomena that don't exist anywhere else, interactions between worlds that seem like science fiction, but are happening right now, billions of miles away from Earth. Every world we study teaches us something new about the incredible diversity of environments that exist in space. The James Webb Space Telescope's discoveries about Pluto also highlight the importance of continued space exploration and scientific research. This groundbreaking research was only possible because we invested in building the most advanced space telescope ever created and pointed it at a world that many people might consider unimportant because it's no longer classified as a full planet. But science doesn't care about classifications. It cares about understanding the truth about our universe, and sometimes that truth is stranger and more wonderful than anything we could have imagined. Looking ahead, scientists are excited about what other secrets Webb might uncover about Pluto and other distant worlds. They're particularly interested in understanding how common this type of haze-controlled climate might be on other cold, distant planets throughout the universe. With thousands of exoplanets now known to exist, many of them cold worlds orbiting far from their stars, understanding Pluto's unique climate system can help us interpret observations of these alien worlds, and perhaps even identify which ones might be capable of supporting some form of life. The discovery also raises intriguing questions about the history of our solar system. How long has Pluto had this atmospheric haze? Has it always controlled the planet's climate this way, or is this a relatively recent development? How do seasonal changes affect the haze over Pluto's incredibly long year? These are questions that Webb's continued observations may help answer in the years to come. What strikes me most about this discovery is how it changes our perspective on what it means for a world to be active and dynamic. We often think of geological activity, like volcanoes and earthquakes, or weather systems, like storms and seasonal changes, as signs of an active world. But Pluto shows us that even a small, cold, distant world can have incredibly complex and dynamic processes happening in its atmosphere. The fact that microscopic particles can control an entire planet's climate system is a reminder that the universe operates on scales both vast and tiny, and that understanding nature requires looking at phenomena across all these different scales. So the next time you look up at the night sky and think about the vast distances between stars and planets, remember that out there at the very edge of our solar system, Pluto is quietly demonstrating climate processes that exist nowhere else we know of. Its ghostly blue haze is working like a cosmic air conditioner, cooling the planet even further than the sun's weak light already allows. Gases are escaping from its atmosphere and traveling to its moon. Ice is constantly moving around on its surface in seasonal cycles that last for decades. All of this is happening right now, as you watch this video, in the cold darkness billions of miles away from Earth. And we're able to study it and understand it because human curiosity and ingenuity have created tools like the James Webb Space Telescope that can reveal the hidden secrets of even the most distant worlds in our cosmic neighborhood. This is why space exploration matters. This is why scientific research matters. Every time we point our most advanced instruments at a new target, whether the galaxy billions of light years away or a dwarf planet at the edge of our own solar system, we discover something that changes our understanding of how the universe works. And in understanding the universe, we better understand our own place within it and the incredible diversity of worlds and phenomena that surround us in the cosmic ocean. If you found this journey to Pluto as fascinating as I did, make sure to hit that like button to let me know what you think about these incredible discoveries. Share this video with anyone you know who loves space and science, because discoveries like this deserve to be celebrated and shared with as many people as possible. And don't forget to subscribe and ring that notification bell, because the James Webb Space Telescope is just getting started. And I guarantee you there are going to be many more mind-blowing discoveries coming our way that will challenge everything we think we know about our universe. The cosmos is full of wonders waiting to be discovered, and we're living in the most exciting time in human history to explore them. Until next time, keep looking up at the stars and wondering what secrets they're waiting to reveal to us.